Hi everyone, and welcome to the 11th video in the Weather Unlocked video series. This video will focus on the different types of clouds that you could potentially see next time you go outside. Now, unless there are clear skies out, we see clouds on a daily basis. However, clouds are extremely complicated. They can grow super tall or look flat as a pancake. They're typically white in appearance, but can also be different shades of gray, yellow, orange, or red. They can weigh tens of millions of tons, yet also float in the atmosphere. They can bring good weather or bad weather. They can be carried along by winds up to 150 miles per hour, or can remain stationary while the winds pass through them. So you can see that just the presence of a generic cloud means almost nothing without more details because of how complicated they are. Now, before we get into the different types of clouds, let's first take a look at how high clouds can form. If you take a look at this image, you'll see three different regions in each hemisphere. There's the polar region, the temperate region, and the tropical region. And the division between each of these regions actually varies from day to day and season to season. You have the polar jet stream, which divides the polar and temperate regions, and the subtropical jet stream, which divides the temperate and tropical regions. Now, one effect of these two jet streams, or these narrow bands of strong wind in the upper levels of the atmosphere, is that the maximum altitude of the tropopause decreases in each region as you move from the equator to the poles. And if you recall from a previous video, the tropopause refers to the boundary between the troposphere, or the lowest layer of the atmosphere, and the stratosphere. So generally, as the height of the tropopause decreases, so does the height at which clouds can occur. But there is an exception when it comes to low clouds, which have cloud bases within the first 6,500 feet of the surface in every region. However, even this isn't always the case. During the summertime, the base of cumulus and cumulonimbus clouds can be much higher than 6,500 feet and can even be well into the mid-level cloud range in the southwestern United States. In fact, cumulus cloud bases have been observed up to 9,000 feet over north-central Texas, and thunderstorms with cloud bases from 11 to 12,000 feet have occurred near San Angelo, Texas. If you take another look at the different regions on the globe, you'll notice that Missouri falls generally in the temperate region, which means mid-level clouds can range anywhere from 6,500 feet up to 23,000 feet, and high-level clouds can climb all the way up to around 45,000 feet. Now, according to the World Meteorological Organization's International Cloud Atlas, there are 10 basic cloud types, each divided by their heights. So let's first dive into the high-level clouds, which are composed mainly of ice crystals and typically have a thin, white appearance. Now, the first type of high-level cloud you can see are cirrus clouds, which are detached clouds that look like white, delicate filaments. Now, sometimes they might even have a fibrous or hair-like appearance and can even look silky or sheen, and they're always composed of ice crystals. Next, you have cirrocumulus clouds, which are thin white patches, sheets, or layers of clouds, and they're composed of very small elements in the form of grains or ripples. And in general, these clouds typically represent a degraded state of cirrus and cirrostratus clouds. And that leads to the last type of high-level cloud, which is the cirrostratus clouds, which are transparent whitish veil clouds that have a fibrous or smooth appearance. Now let's move on now to the mid-level clouds. These are composed primarily of water droplets, but can still be composed of ice crystals when the temperature is low enough. The first mid-level clouds are the altocumulus clouds, and these are white or gray patches, sheets, or layers of clouds, and are the most common mid-level clouds. You can have more than one layer of altocumulus appear at different levels at the same time, and these will most likely appear with other cloud types. Next, we have altostratus clouds, which are gray or bluish sheets of fibrous clouds that either totally or partially cover the sky. And these clouds are thin enough to see the sun through them and can have light precipitation occurring at times. And the final mid-level cloud type is the nimbostratus cloud that results from thickening altostratus clouds. Now, these clouds are typically a dark gray cloud layer diffused by falling rain or snow and are thick enough to completely hide the sun. Because the base of these clouds lowers as precipitation occurs, it can sometimes be referred to as a low-level cloud. And lastly, we have the low-level clouds, which are primarily composed of water droplets. So starting out, we have cumulus clouds, which are detached and generally dense clouds. Now, these typically have sharp outlines that develop vertically in the form of rising domes or towers. And the sunlit parts of these clouds are mostly white, while their bases are relatively dark and horizontal. When these clouds develop over land, they typically develop on clear sky days and form due to the diurnal convection, meaning they appear in the morning, grow throughout the day, and then more or less dissolve again towards the evening. Now, there's also cumulonimbus clouds, which is considered the thunderstorm cloud. This is a heavy and dense cloud in the form of a mountain or tower and can extend all the way up into the high-level clouds. Now, the upper portion of the cumulonimbus clouds are usually smooth, fibrous, and nearly always flattened in the shape of an anvil. And towards the base of the clouds, there's often low, rugged clouds that produce precipitation. And these are also the types of clouds that can produce hail and tornadoes. Next, we have stratocumulus clouds, which are gray or whitish patches, sheets, or layered clouds, and these almost always have a roll-like or honeycomb appearance. And then the last low-level cloud type is stratus, which is generally gray cloud layer with a uniform base. Now, if these clouds are thick enough, they could produce drizzle, ice prisms, or snow grains. So those are the 10 basic cloud types, but there's also more unusual types of clouds, meaning they're not as common or aren't typically seen every day. The first are mammatus clouds, which are generally associated with thunderstorms, but don't necessarily indicate severe weather. These clouds are basically upside-down clouds and result when moist air sinks down into dry air. Next, we have wall clouds, which is another cloud formation that's associated with thunderstorms and is a lowering of the cloud base typically under the rain-free portion of a cumulonimbus cloud. It's also a pretty good indicator of where the strongest updraft is located, and a rotating wall cloud is the area of the thunderstorm that's most likely to produce a tornado. Third, we have a shelf cloud, which is a low horizontal wedge-shaped cloud that can either be associated with a thunderstorm gust front or can occur with a cold front regardless of if there are thunderstorms or not. And when you look at the leading part of the shelf cloud, you'll notice a rising motion, and then the underside usually looks pretty turbulent and wind-torn. Now, asperitas is observed when atmospheric waves propagate near the base of the clouds, making these clouds appear as well-defined, wave-like structures in the underside of the cloud, almost as if you're viewing a roughened sea surface from below. Next is virga, which is just precipitation that evaporates before reaching the ground. And lastly, as I'm sure most of us have observed, there's fog, which is a ground-level cloud that lifts from the surface and either becomes stratus or dissipates with the heat from the sun, and it usually reduces the horizontal visibility to less than 5/8 of a mile. Now, there is a cloud chart that shows different variations and pictures of each of the 10 basic cloud types, so if you'd like more information or just want to see more pictures of the different clouds, you can visit this website and click on each picture to learn more. So that concludes today's video on the different cloud types, so stay tuned for future videos in the Weather Unlocked video series.